Analytics Webinar. This webinar is being run by the WA Data Science Innovation Hub in partnership with WISE and AusCyber, which is the AusCyber WA Innovation Hub as well. And we do have Simon speaking from the AusCyber WA Innovation Hub, so I will get him to provide a bit more detail later. So what I want to do is I will introduce the speakers each individually as they come up to speak. Really what we're looking at today is how to unlock the value of IoT data. So how can your company benefit from IoT analytics, data acquisition through IoT, as well as some of the barriers to IoT data analytics adoption in relation to cybersecurity and IoT security. So I just quickly, before we get started, I'll just give everyone a bit of an overview of the WA Data Science Innovation Hub and the WISE program as well. Most of you have probably been to one of our webinars before, but just as a quick recap, we are really, the purpose of the WA Data Science Innovation Hub is to really accelerate the uptake of data science within WA businesses. We look to build capability within businesses, organisations across Western Australia around data science, enable a self-growing data science community within WA, and help businesses to flourish through the uptake of data science. This is just our website. There's quite a lot of information on here, so events in WA, but also more broadly across Australia. We've got a lot of information around upskilling in data science online and face-to-face. We profile data scientists, various projects happening in WA around data science, and some good news and blog articles there as well. So feel free to jump on the website and have a look through the information we have on there. Now a little bit on WISE. So WISE stands for the Wireless Industrial Sensor Environment, and it is part of Innovation Central, which is located out at Curtin University out of Bentley. WISE is very much a program around collaboration. So solution development using collaborative techniques. So it is a member-based organisation, and members come together to solve problems together. It's also sort of supported by NERA, which is one of the federal government's industry growth centres. So what are the key features of WISE? It's access to talent. So you get consultation and advice from the WISE people and ICP, and face-to-face tutorials as well around installing sensors and analysing the data outputs. There's a digital kitchen based out at Bentley, which is great. So you can use that digital kitchen, use prototyping and the like. You get access to all the current infrastructure and open innovation and collaboration, as I said, with other WISE members. If you want some more information on the WISE program, there is a link there below. Otherwise, feel free to contact myself at the WA Data Science Innovation Hub, and we'll provide more information on that. Okay, so straight into it. So I will introduce the first speaker. We have Zdravka Paskaleva-Newman, who is a Business Development Manager at Cisco. So Zdravka has spent 16 years at Cisco and is a Cisco veteran. She has held various roles within the company, expanding between sales, strategy and consulting. Working in both Europe and Hong Kong, her experience includes taking ownership of the Smart and Connected Communities Charter of the Netherlands, including developing strategy around the role of technologies for sustainable urban development. Currently, Zdravka is leading Cisco Smart and Connected Communities business development in ASPAC. In this role, she engages with city officials, government and urban service providers across the region. Zdravka will discuss smart cities, the current trends, technologies and approaches referring to real experiences from around the world. Zdravka, I will pass over to you. Thank you.
Good morning, everyone, and thank you so much for having me here today. I am going to share, just bear a minute with me. All right, is it coming out okay?
Yep, Great.
Can you hear me?
Yep.
Good.
Perfect.
Excellent. Yes, based out of Hong Kong, looking after the Asia market around smart cities. And of course, it has a lot of intersection and overlaps with IoT. Obviously, IoT is the bigger foundation around what we're seeing happening in smart cities. So I'll walk you a little bit through what we have done, mostly focusing on projects that we've seen across the globe and some of the technologies and the use cases predominantly in the scope that cities are looking into those projects. Just a quick summary. I think maybe a lot of you who are active in the smart city space, these slides will not be anything new to you, but it's important to see what cities are defining in terms of smart cities and what are the use cases they're looking at. So we see a lot of projects that are spanning across smart street lighting, smart parking, roadways, especially in Australia, a lot of happening around connected roadways. Waste is also becoming quite an interesting topic. How can you automate collection of waste, making it more efficient and so forth. And safety and security. There are different discussions around privacy, obviously, when we talk about safety and security, and varies from city to city, but it's becoming a very prominent use case. And what is important also to talk about when we are looking at the use cases is the explosion of technologies. And it's not, unfortunately, only IoT technologies. Of course, there is also the fiber and connected infrastructure that plays a lot of role in some of those use cases, as well as obviously cellular and BIoT, which is a lot more on the IoT side, but Wi-Fi is also still a big discussion around how to provide the access layer to access connectivity for those use cases. So all of that is making cities obviously thinking about digitization. However, there is not one thing that fits all. And I think the challenges that we are currently looking that a city are facing are a lot around how do they make the choices of the technologies that they will deploy when they're delivering those use cases. A lot of the solutions that are out there at the moment, unfortunately, are vertically integrated, which means you either have only a smart lighting solution or you're having only a smart parking solution or a smart waste solution. So that means that a lot of the infrastructure that has to come into place to serve those individual use cases may be duplicated. And obviously the objective for cities is to look how can they actually provide and look at infrastructure from access technology perspective that fits many different use cases. There are no open standards yet. There's a lot of proprietary technologies out there. So again, posing a lot of challenges around open architecture and how can you manage the entire city from one single place rather than going and logging in into many different applications. So something that cities are looking at, and we'll talk a little later about the examples, is how do they have that one single pane of glass? Another things that we are looking at is a lot of the disjointed ecosystems. So you have none of these use cases, once they become together, they have to interoperate together. And there's a lot of, we're seeing that there's still a long way to go of building that ecosystem that everything fits with each other. In terms of approach, this is more of a very holistic way of looking at what technology companies are bringing into the market and how cities are trying to put together the architecture and the scope of the whole city. It really comes out to a couple of things. Horizontally, it comes out to an infrastructure of some sort, right? The network, and there's, again, as I mentioned before, a lot of different technologies that are coming into play, makes it very difficult to make choices of, are you putting a Wi-Fi infrastructure, are you putting a LoRa infrastructure, are you putting an RF mesh infrastructure? How many use cases can you carry on one of those technologies? So that is the first thing that a lot of companies like Cisco as well are looking into, is how can we have more of an aggregated infrastructure that serves multiple use cases. The second thing is the single pane of glass, some sort of platform. There's a lot in the market at the moment in terms of platforms. The idea is to have an agnostic and automated way of aggregating these use cases into that single pane of glass. It has to be painless, the way that data flows into that platform. And I think there is a lot of innovation still happening in that space. Other things, as I said, previously, I'm just going to skip real quick because we only have the 10 minutes per speaker, I realized. We also see, of course, all the different entry points. So some cities will just start with one. As long as the connectivity is open, the architecture is open, you're able as a city to scale across the other use cases. If you look at some of those those vertical types of solutions. Smart lighting is a great example, by the way, in Australia, because we see that we have it's a large territory. There's lighting in huge amount of square kilometers, especially in WA, for example. And if you have an infrastructure that provides the smart lighting, that same infrastructure should be reusable for other use cases. And I think that a lot of the smart city deployments start from lighting. So the single pane of glass, a lot of you probably who are in the space, again, have seen things like that, many of those. The idea is to really have that automated integration, painless, and for a city operator to be able to see and operate the city from one single place. It's not just seeing it, but actually also command and control kind of capabilities that are coming into it. So let me dive into a few examples of what we have done and what we are seeing happening across the world. So first, a real quick zoom into APJC. Everywhere we see actually a very strong activity around smart cities. India, to be honest, led the way with their smart city mission, which started 4 years ago. They've already done 64. The way they've done it is quite holistic. It's all the bottom up, ground up, infrastructure everywhere, IoT everywhere, applications. So it's quite easy in some of those deployments because it was a lot of greenfield. In developed countries like Australia, it's a lot more different, the approach, right? You have a legacy infrastructure that you have to keep on utilizing. However, we also see a lot of activity still in Australia. There were a lot of grants last couple of years, and now we're seeing also because of COVID additional grants coming in, and smart cities and especially roads are becoming an important part of that investment. Across the region, there's a lot of other things happening. In Japan, super cities, they're supposed to be completely autonomous, and a lot of the funding for that actually will be coming from the COVID stimulus packages. A couple of cities concretely, what they've done, this is a city in India for 4 million population. It's a quite touristy, or used to be pre-COVID, quite a touristy city. What they did is, again, that the type of project where they did a bottom-up sort of building all the infrastructure, all the applications and connectivity. You can see that in the middle of the photo here is actually the command and control center, which brings video surveillance in, video analytics in, that helps them operate the roads or monitor, crowds and behavior analytics. They have the parking, they have the lighting, they have a lot of environment sensors. They even have an infrastructure sensors monitoring the old buildings. They have a lot of old buildings in the city. So these are some of the use cases they have done. Another deployment quickly around smart cities. This is an example in Greece, a city called Trikala, not very big city. What I like about this deployment is that they actually brought the entire visualization of the use cases and what they have deployed in the city hall. So as a citizen, if you go in, you can actually see it. So that made the, adoption by the population of the city quite much easier, because a lot of people are asking, what is smart city? What are you doing with the data? What are you seeing? So that was all in display in the city hall. They did 3 simple use cases. They did lighting, parking, and Wi-Fi. And what they did with public Wi-Fi is they also monitored. And that's, again, a big discussion I know in Australia around privacy. They just monitored the unique users. So that helped them think about urban planning in certain places of the city. And talking about analytics, this was a pilot stage. They did about 100 or so parking spots, 50 lights, and maybe 20 or 30 Wi-Fis in the CBD. So it's not a huge deployment, but it was supposed to scale up, and it will scale up. The way they did it is they looked at the results to make a business case around it. So they looked at how they optimize parking. Are they collecting more money? Are they preventing, wrongly parked? Which parking spots are more occupied compared to others? They looked obviously at smart lighting is a quite easy return on investment use case because they looked at what is the consumption and the energy spent and savings that they were able to utilize. And lastly, they looked at the unique users around from the Wi-Fi deployment. The next example is, and Liz, stop me if I'm over time because I lost track. The next deployment is in Singapore. This is a prototype of their single pane of glass. They looked at a lot of their use cases. I'm not sure they will be very translatable in Australian context, but they did look a lot around video analytics. So if you look at this dashboard that they are pulling the information from, most of the use cases are around mobility. So are the counting bicycles, the counting personal mobility devices like scooter. Other use cases are around crowded bus stops, so they can optimize the flow of the public transport. They also looked at road crossing so that they can optimize the traffic light systems. And the last one is something that only the police, by the way, has access to it, which is around people of interest and vehicle of interest, where they're tracing face and license plate recognition. Now, the reason they wanted to build it all together is to help the different agencies, because all of these use cases serve actually from administrative point of view, they're serving different type of agencies. They wanted to enhance that collaboration because one of the key prerequisites for successful smart cities is really the cross-departmental collaboration within the city and exchanging that data between the city departments. Obviously, sensitive data, what the police has access to, has been is not actually what we are having here is just a snapshot. I don't have obviously access to the actual data. This was more for making for presenting the case. However, the other agencies can only see what is relevant for them. But the idea was of enhancing that collaboration. And they also had some use cases around, quite interesting use cases around traffic. So, and using different type of technology like DSRCs, so they can send real-time information to passing cars, especially around environment and around upcoming conditions on the road. Obviously, they have a lot of rain. They had flooding, so they want cars and drivers to be aware that, a kilometer or 500 meters ahead is slippery, etc. I think this is my last example. Yes, this is Japan, Kyoto. If you've been to Kyoto, Kyoto is, again, it's an old city, and it's quite interesting to see how they mixed modern with old. The idea here is, again, a lot around boosting tourist experience, really. However, they looked at multiple use cases. So the most predominant use cases were around smart kiosks and how to help navigate the tourists' flow across the city to go to the least busiest attractions, because the waits are quite long always. However, they use that opportunity to enhance the experience. So they've deployed public Wi-Fi, they've deployed environmental monitoring, smart parking and smart lighting, and again, coming together into that one view and single pane of operations within the city operator. And so I'll close here by saying it's a journey we've been, as me, myself, and as a company, I've been on this journey for more than 12 years. We've seen a lot of the prerequisites are around bringing the people as part of the project, creating the new ecosystem, having the cross-departmental collaboration, and promoting open standards and the interoperability between all the technologies that are out there, so the cities do not get locked into one single type of technology. Thank you very much.
Fantastic, thank you, Zrebka. And I meant to tell the participants that please put questions through the Q&A chat as well that you can open up. So happy to take your questions, but we will leave all questions for all speakers to the end. So if you do have a specific question for a specific speaker, please let us know who the question is for. That would be great. Thank you very much. I have questions, but I'll leave them to the end.
Sure.
We will now move on to our second speaker, James Colbert. James is currently the Regional Director for the Smart Grid Services Division for Schneider Electric across East Asia and the Pacific regions. James has spent over a decade operating in dynamic and challenging environments, from startups to global organisations, and he's been closely involved in the digitisation of the energy sector, driving business development and growth within the rapid changing energy landscape. Prior to joining Schneider Electric, James led the strategy and market development for energy technology business Edge Electrons and was the GM of Strategy for Energy Australia, where his role encompassed overall strategy, as well as new technologies and businesses, including smart grid, smart city, embedded networks, smart metering, EVs, and storage. So today, James will focus on the energy landscape and highlight how IoT and data are enabling and driving change in the sector, as well as some of the challenges faced. So James, I will hand over to you. Thanks.
Thanks, Liz. And can everyone see, can you see my screen okay? Perfect, wonderful. Thanks everyone, and look forward to sharing some of the insights from Schneider with you as we go. Sorry, just the screen going. So first of all, for those who aren't familiar with Schneider Electric, we provide energy and automation digital solutions for efficiency and sustainability. We're a 180-year-old business operating across 100 markets in the smart grid solution space. We have a bit of an interesting perspective in that we've gone through our own digital evolution and investments in IoT and the like and analytics. We cover pretty much anything in energy and automation, from the smart grid software which runs the networks, through to demand response, through to the light switches in your house, which people will be familiar with, the Clipsal brand in Australia, which gives us an interesting insight when we look at our business globally. It's 30% Europe, 30% North America, 30% Asia, and then the rest of the world's the remainder. So as we go through what we're seeing across the energy industry in particular and the evolution and how AI will play into that, we're seeing a significant transition. We're looking at massive pillars of electrification where we see 3 times electricity consumption growing by 2035, and this is driven by the pervasive adoption of ICT. So if we look at the Australian example, we're seeing businesses like Leading Edge with data centres in regional areas driving the 5G rollout, which opens up new applications for AI and also IoT type technologies. The drive for decentralisation is nowhere more pervasive than Perth. We look at what's happening with Western Power and the flexibility services side there, where they're seeing so much solar that needs to now be absorbed by increasing generation. We see that as growing across the world by 50% of it by 2050 in terms of decentralised energy. What this means is how this is managed and the capabilities which companies need really are going to be driven by the intelligence and processing at the edge of grid. Decarbonisation I won't spend a lot of time on, but we're all very familiar with what's happening, and that by 2040, 95% of the 2-degree carbon budget will be consumed by existing infrastructure. And really, when we're talking about the AI and analytics aspects, there's nowhere stronger than digitisation and the cost savings which can be achieved through that by customers and their projects. And we're seeing this across the world in different markets, but we are seeing Australia right at the forefront of that. So as Schneider, what we look at is around how do you innovate and what the different models and products are. So if you look at innovation at the edge, which is an area of our business where we're investing about €500 million in technologies, it's around taking innovation at the core. What do we do in our business and what do we do at the edge? And how do we do that with partnerships, incubation and joint ventures? But how do we also drive new products, new features and R&D? So if we look at that sort of aspect and the ideas, and really when we talk about AI, and that's at the core, one of the pillars we're focused on, which I'll talk through a little bit, but we look at partnering, co-innovating with startups, proof of concepts, piloting and scale-ups, investing directly. So how do we actually invest in businesses? Incubating new businesses. So if we think about some of the applications and the benefits of data, do we spin out our own business? We're looking at one at the moment on vegetation management using advanced analytics and insights to say, is it more intelligent to actually replace and remove the lines and put in, say, standalone power stations, which Western Power is doing now. And then it comes to joint ventures. So if we talk about the areas of focus, AI is one of the key ones, and it actually applies across most of these buckets here. So we think about energy management and electric mobility. Currently, we've set up a business called EIQ Mobility in North America, which will help fleets move to electrical fleets and actually digitize their fleet, be able to manage the EVs within it, how they charge, what the patterns are. We're also seeing that in transport. I think in Perth, there's an announcement with Volvo on an electric bus. In North America, we're seeing companies like Proterra setting new records for distance. And we're saying, how do you use AI to say, well, actually, can these buses and fleets of buses and the depots, how does that interact with the grid to work out where are they going to charge, how do they charge, and what's the available capacity in those? So you talk about smart buildings and the intelligent buildings. We're looking at how you can use the intelligence in a building management system to actually use the thermal inertia in a building, which means turning it on at different times of the day to store energy and reduce the cost of running it, or pre-cool or turn it off at times to support the network or demand response. Now you look at the future there and you said about distributor alternatives, what's the road of B2B e-commerce and then IoT and robotics? Each of those are really at the core of how AI can support, and with cybersecurity, we'll be talking about later, but we're seeing that in Australia in particular, where you're looking at things like the Department of Home Affairs and the Critical Infrastructure Act. What data is allowed to be kept onshore? What security does it have? And then how do you actually manage that? Whereas historically it may have been done by people remotely in other countries. So in terms of what is AI's potential and what can it do in terms of greenhouse gas reduction, some analysis which has been done by PwC, I thought was a nice point, that you can look at AI enabling just through energy alone a 2.2% reduction compared to the BAU scenarios. In terms of specific applications, what we're seeing is managing the grid more efficiently, monitor connected critical assets, grid lines, equipment through condition. Apologies, I just had a 6-year-old wander in. Adding renewable energy to the grid, so improving performance and resilience of distributed generation microgrids, optimised solar assets, batteries and wind farms. What this means is being able to actually take the data, run it quickly, optimise those assets and have them operate in a new way. Historically, there's 2 million solar systems out there and none of them are visible. What we're looking at now is being able to do synthetic models of those, digital twins if you'd like, and then be able to have the network dispatch those. It actually flows through to one of the businesses we've invested in and are doing a lot with AutoGrid, which realistically will take the data, drive power usage insights, and it runs about 10 million predictions every 10 minutes. To give you an idea of what that means, it's the ability now to predict and control what the energy is happening at the edge of grid. In many markets, there are not smart meters. There is no intelligence. If you can imagine a $32 billion asset which can't see what's at the end of it. And so we're using capabilities such as AutoGrid or ADMS and DERMS, different platforms, using AI to actually support the network operators or the wholesale market operators if you're a generation retailer. So in terms of time, I'm conscious of getting through within the 10 minutes. I thought I'll talk through just the areas of investment interest that we have at the moment. So the first is around zero engineering. So how do you actually look at design, engineering, configuring for operations and business requirements with changes dynamically and design for autonomy from the beginning? Then you look at the zero commissioning. How do you do this without having to actually send someone out there, sending out a device which when the customer opens the box, it's automatically connected to their smart meter and tells them what's happening in their usage. It might be for other devices. We're seeing this in grid operators as well there. Connected sites, so self-managing devices, remote control, system level cybersecurity is another big one for us. And you talk about its interesting aspects there where we're now able to have the intelligence in an iPad, for example, picking up a specific of connecting to a device inside what's called a kiosk, a heavy engineering piece which goes into the grid, and it can diagnose remotely what is the predictive failure of that asset. What is the actual real asset life? Because you're talking about a 40-year asset. What is the degradation versus the others? Whereas historically these tests were done via opening them up, doing a detailed oil analysis test, and then which is very costly and time consuming. Whereas now you're able to actually drop in a small IoT device, either retrospectively or new, and see what that predicts for the future of that. The connected workforce, most people will be very familiar with, but when you look at the ability to actually route people to the right assets at the right time, we're seeing significant change in the OPEX and capability there for the customer. And lastly, autonomous operations is one which everyone on this call will be very familiar with in the applications for AI there. We are seeing a lot of that happen, particularly in the network operator space and the grid operator. And we saw from Cisco about how they can play up to a broader state-based view in Singapore. With that, I hope that shared some of the insights we're looking at for Schneider and what's happening with AI. And thank you very much, Liz.
Thank you so much, James. Sorry, there's a bit of feedback. Okay. Thank you, and I do appreciate James is based in Melbourne, so he's juggling presenting webinars and homeschooling. So I do appreciate your time. We'll move straight on to our third and final speaker, who is Simon Carabetta, who is the Project and Engagement Coordinator at the WA Oz Cyber Innovation Hub. So Simon is a high school teacher has been a high school teacher for over 12 years and has taken his passion for education and brought it with him to his career of cybersecurity advocacy and awareness building. Simon was the designer of the WA Water Corporation's first ever employee cybersecurity education program and is well versed on the security issues that industrial and consumer IoT devices produce. So today, Simon will discuss security risks that industrial IoT creates in terms of data and access control and what controls and measures can be put in place. So I will hand over to Simon. Thank you. Simon, you should just be able to override that screen share as well, I'm hoping.
Thank you. Thank you very much for that. It's the second time in 2 weeks I've forgot to click the mute button. Yes, thank you very much, Dr. Liz, for the introduction. And indeed, thank you, Zdrava and James, for that very insightful presentation. Now we get to the security part. And usually when we get to this, it's the boogeyman's going to tell us all the scary stuff and the blockers coming. But no, that's certainly not what cybersecurity is about. Cybersecurity, I believe, is about empowerment and enabling people to navigate the digital landscape in a safer way. I mean, we do currently have a very hostile digital landscape. You only have to watch the news and read the papers and see what's going on. So when we talk about things like smart cities and IoT and connected devices, a lot of the time security is at the very forefront of what people are thinking. But the problem with a lot of IoT is that security is either an afterthought or it really is a non-thought. I believe that Professor Craig Valley at the Security Research Institute at Edith Cowan University has called IoT on more than one occasion the Internet of Threats, and it certainly is. But at the same time, I mean, I'm a big advocate for smart cities, and I'm a big advocate for internet connected devices, and I don't believe that in any way we should be, we should be stopping the use of these things and definitely not holding back on smart cities. But what we do need to do is definitely raise awareness of what the threats are, because they very much do exist, and how we can actually navigate a lot safer. So I'll direct you quickly to a SANS Institute paper from earlier this year, actually, where they talked about three things that organizations should be asking themselves when it comes to IoT. The first question is, are they aware of every new and existing IoT device on their network? The second one is, have they assessed how there is a potential risk for each of these devices? And the final question is, have they assessed how they're going to respond to a threat if there is any suspicious traffic stemming from any particular device on the network? And you'll find that the answer to those questions in most organizations is no. We don't know any of that. We don't actually know what IoT is on our network. We don't know how to respond to these. And if there was a problem, we wouldn't even know how to detect it. The thing about IoT, as I said earlier, it's a bit of an afterthought when it comes to security. So if I go and buy a new phone, for example, I know that when I'm purchasing that phone, whether it's Samsung or an iPhone, I know that there is already going to be firewall protection, there's some endpoint protection on that device, there's going to be possibly antivirus and a lot of other controls in place. When I purchase at a consumer level, I purchase an IoT device, whether it be like a smart TV, for example, a lot of that isn't actually stock standard. It doesn't come with the actual device. You'll find that a lot of the time people just go and at a consumer level, again, will go and install these devices on their network at home without really thinking of security at all. And you can probably do that with a phone to a level, but with like a smart TV, you certainly can't, especially when you find that, the default passwords admin. That's a huge issue. And it's something that we really do need to start raising a lot more awareness about at a consumer, but also at an enterprise level as well, because we talk about also industrial IoT, and we talk about that separation of the IT and OT as well, which is also very, very critical. And speaking of critical, when we talk about things like critical infrastructure, the power grid, water, we really need to start thinking about the separation of those two things, but also at the same time, the industrial IoT, how is that being secured, and what controls are in place, particularly when you talk about your SCADA systems as well. we're looking at, by 2025, there was a Gartner paper that said by 2025 we'll have something like ridiculous, like 21 billion IoT devices in circulation around the world. There's been other organizations that have come out and said by that time we might have 35 billion IoT, so connected internet devices around the world. You got to really think how secure are all these devices, and potentially how many threats are out there, because when you look at IoT, probably the first threat we look at is a distributed denial of service attack, which is when, if you don't know what that is, a DDoS attack, it's when you can threat actor can take control of these IoT devices, turn them into zombie bots, which can then actually overload an organization's and enterprise's network, and then thus disabling their website, which is used for services at a consumer level, and then can shut down the business for a significant amount of time, which can actually really impact the business. So this can happen definitely when an IoT device is not protected. It hasn't got any kind of shielding from any kind of compromise. Apart from that, we look at data breaches as well. So when we talk about IoT and data and where our data is being stored and how secure is that data as well, is there personal identifiable information included in that data? IoT data is great at an enterprise level for marketing purposes and for consumers, and for sales. But at the same time, where is that data being stored and how secure is that? And when it comes to things like PII, is that really a necessity in some circumstances? When we talk about smart cities as well, it's great. And Zdravko, I love your presentation and a lot of the things that are happening around the world at the moment in terms of smart cities and IoT. But at the same time, what type of data is out there, and do we really need things like people's personal information being stored, and is it stored for X number of years, and how secure is that as well? So that's a real concern sometimes when you do talk about smart cities. Again, smart cities great, innovative, and again, internet connected devices. I think we're at the point now in the world where we actually need them. People expect to have some kind of connectivity with a range of appliances and devices that were once upon a time not able to connect, but now that's an expectation. So we also need to raise the awareness that security is also an expectation, and that needs to be at the very forefront and by design all throughout the creation of the product, no matter what that IoT device is, and no matter where it sits, and no matter what you do with it. Security definitely very much needs to be at the forefront. So at an enterprise level, there was also another Gartner paper that said, and that was released late last year, that said by 2020, so where we are now, there would be 5.8 billion enterprise IoT devices around the world as well. So again, you go back to those three questions. Do we know what IoT we have on our network? Do we know what threats they pose, and do we know what to do about them? And I think that we're at the point now where you need to start saying yes. We have taken inventory. We know what's on there. We do know what the threats are, what they pose, and how at risk we are with these devices. And yes, we do know how to detect, and we do know what to do if there is suspicious traffic coming from these devices. It just very much has to be at the forefront of the way we think. It very much cannot be an afterthought anymore, and that's just the world we live in at the moment. But at the same time, it's all about empowerment and making sure that people know how to navigate that landscape better. For example, if I get in the car, I know very well in the back of my mind that crashes are a thing. If you're not safe, you're going to crash. But we don't want people to stop driving. So it goes very much the same with IoT. We don't want people to stop using internet connected devices. They very much serve a purpose. But at the same time, we want them to be security conscious at all times. Thank you.
Fantastic, thank you, Simon. And I like your glass half full attitude that you take to cybersecurity. So that's it from our speakers. So we've got a couple of questions coming through on the chat. So I'll open it up. The first one is around smart cities. So Zradka, this might be one for you, and James, I might get you to chime in as well. So. And James, you did sort of touch on electric vehicles a little bit in your talk, but with the uptake of electric vehicles and it sort of presents multiple opportunities and also challenges for utilities, can IoT platforms communicate, control EVs to enable smart charging and analytics with open protocols and messaging? And James, you did touch on this a little bit. Or do IoT solutions need specific compliance like OCPP to handshake with EVs? So James, I might sort of throw this one to you, as you did touch on EVs a little bit, and then Zradka, if you've got any comments as well.
Yeah, look, there's two parts to this. There's some challenges. Firstly, the telematics in their cars. There's two different parts of communication. There's one communicating to the EV charger, which is relatively simple and feasible. We make EV chargers and we can do that. They've got metering and all the comms in them. That's not an issue. However, in terms of the vehicle, that's where it becomes a little bit more challenging. There's also the considerations, and people are talking about vehicle to grid often. It varies by manufacturer, and it's a very early stage area because there's also a significant impact to the degradation of the battery life. And if you're an EV owner, think about it from that lens. You bought a car, whether it's a Tesla or a Nissan Leaf, it doesn't matter. That's a far more significant purchase than the couple of dollars you might get for charging a vehicle and using it to support the grid and the interaction there. So it's technically feasible. However, the question isn't really necessarily the technical side, it's what's the customer value proposition and when will it happen. Perth, I think there's 200 EVs and Australia's got the lowest adoption in the world. But yeah, the protocols and communications are feasible, but you do need the telematics in the car to work with it as well, which is a bigger challenge. As you'd imagine, there's a huge competitiveness in drivetrains and in battery technologies in those vehicles.
Zradka, did you have any comments on that as well, the EVs?
Sure. I would more like to comment on the business models for utilities, the first part of the comment here. We actually have seen, I personally have worked with a couple of utilities looking into how to obviously embrace EV, right? And how they can actually provide it as a service in different ways so that it doesn't necessarily impact, it's there, right? They have to embrace the change so it doesn't necessarily impact their bottom line of revenue. The other thing I was going to mention around the technology of EV charging stations particularly, right? So we see utilities putting them in, they have certain transformation of the business model, what they charge for it, the way it looks either with the city or directly with the consumer. We have actually looked into integrating some of those, although it's not really a smart city use case, I would say, but because if you, from where we stand, right, we look at smart cities a lot more at the operational side of the basic infrastructure that city is responsible. EV is kind of more between utility and a city. However, we've integrated in a couple of places. And what we actually have used there from technical perspective is APIs, and that will be probably some of the comments I'll do in the other questions. We're really looking at, so there are various ways, right? You can integrate hardware to hardware, or you can actually look at the APIs as a method of integration. And that's what we've done to monitor the consumption, the usability of those stations.
Sorry. And so that, I think, leads then on to probably the next question around the data itself, and you know, where is that data house? Where is it living within the solutions that you both spoke about, and how do you enable that kind of correlation? And maybe it's APIs talking between assets and the data sources. So do you have comments around that? So Zradka, I might start with you to continue on.
Sure. Yeah, I would say we're a little bit, our architecture and what we promote is API type of integration. Now, that does possess some challenges, obviously, because if the particular solution does not come with a accompanying application, so to speak, or software that actually manages that solution, it you have to build that software first and the API to be exposed to the platform to integrate it. What we do promote, though, outside of the APIs is data models within the platform. So what we are seeing right now in the IoT space, because there is not really very large projects with some exceptions in terms of number of devices and number of devices that are flowing data into the platform, we're seeing a lot of, connector by connector type of integration where you just build it, you bring that particular device in and the pilot is up and running. What we promote is data models. So we look, for example, in the way we look at the platforms is, let's say, smart lighting. We know that there are hundreds at the moment smart lighting vendors out there. But what lighting does is on and off, controlling, scheduling the lighting, measuring the consumption of a particular individual light. So we understand the parameters, and that's what we define in the data model. Once these parameters are there, the integration of whoever vendor is there providing, because a lot of companies, we as Cisco do not provide that, for example, but we do want to automate that integration. So that's what we are looking at. And once it's all there, the data models allow that correlation. So these are some of the things that we are driving in terms of open architecture.
James, did you have good comments on, I guess, the process that Schneider Electric takes?
Yeah, so look, it does vary by application and line of business, and in some cases, as Simon will be able to attest to, there's some types of businesses where you actually want to keep it very segregated. So it might be that you have the core data hosted in a very secure area with very, very high levels of security, particularly when you're talking about critical infrastructure, and then you have a very narrow connection to the layer which is sitting outside controlling the assets disparately. If you think about one of the biggest concerns is what are the points of entry and how do you minimize the risk of if they can get into one entry point not being able to permeate the entire network. So there isn't a one size fits all answer. It depends on what's the application, what is the type of business you're running, and then how do you make sure that it's secure in the optimal way. APIs form a key part of it, but we really try and keep separate certain IT, OT layers in particular, and then the edge devices will have very strong encryption and cybersecurity built into them as well. Simon, I don't know if you've got further comments on that side with your expertise.
Yeah, thanks, James. Definitely do. I think you touched on quite a bit there, but it's really important to look at the architecture of the security that you have in place. So you've got your firewalls and you've got that DMZ separating them from separating the edge from the enterprise network, but at the same time that having that OT separated as well is absolutely critical this day and age. Yeah, no, I think you definitely touched on that, James. I think you answered that part for me. It's really good.
And I know that AusCyber's doing a lot around the critical infrastructure, aren't they, as well?
Yeah, we certainly are. Yeah, definitely. I mean, we're working with lots of areas of industry and government, and critical infrastructure has been on the radar for a while and will continue to be.
Yep. I'll just throw this out there. IoT open standards. Does anyone want to comment on the open standards and any sort of, are you advocating for any particular open standards for agnostic platforms? No.
No real comment from my side, sorry.
Okay.
I would say something on the connectivity layer first. I mean, obviously I talked about APIs, so for us that's it. Now, how do you define the APIs has become a bit of still a challenge because there are different groups of what should be exactly the APIs that should become the standard. But on the connectivity layer, I would say we really are promoting a couple of things, and that's maybe not exactly on the platform, but it's more on the infrastructure side. But still, we're looking at obviously 5G, Wi-Fi 6, and LoRa and Wi-Fi as some of the more predominant protocols at the moment, if that helps.
Perfect. So I just have a question from myself, and James, you did sort of touch on this a bit, but it's really the future of smart cities. So how do we start kind of evolving the predictive analytics and looking at those connected assets across smart cities and using more of the AI type of applications, machine learning, broadly across smart cities? I'm not sure how much AI is sort of being embedded into the case studies that you gave around predictive type of analytics. it's definitely within Western Australia in, say, the resource companies and integrating assets and looking at predictive maintenance and things like that. Is that coming for smart cities? Is that sort of the next step in your mind?
Yeah, look, we're certainly seeing that occur when, at the end of the day, we play across building management systems through to industrial automation, through to the grid side of it, and we're seeing more and more of these decisions being made. One of the challenges, though, is particularly for the developed world, the brownfield retrofit cost of digitising things is high versus making the decisions in terms of the specification and procurement for new sites. That's relatively easy. People can say, yep, I'm going to put intelligence in it. Yes, we can do more. But for a smart city, you need a mix of both core infrastructure being upgraded and the willingness to invest in that. And I think the business case isn't as yet proven. We're seeing some decisions on that front and some big ones, whether it be intelligent lights, very intelligent street lights with the ability to adopt there and supporting the deployment of mobile networks. We're doing pilots at the moment with EV chargers integrated into the poles for councils and those things. But one of the big challenges for us as a developed nation is how do you make a city smart without a huge capital cost?
It's very good. You touched on that a bit in terms of legacy systems as well that developed countries have to deal with.
Yes.
Very good. Yeah. Comment?
Yes, I mean on the challenge of deployment, even the smart cities without the predictive analytics, just bringing connecting devices is still challenging, let alone come to that. But in some of the projects I showed, we are looking at the next level. So a lot of analytics are there, but they're more on the correlation that we talked before, right? So if I have a did I consume more lighting or more energy? Did this light consume more lighting or more energy because there were more people passing by and the light is configured to go on and off when there is an activity around it? For example, this is more looking backwards, right? Looking forward, there are obviously recommendation engines embedded in those solutions. They're just being not activated because of the obviously of the cost and making the business case clear. However, we're seeing, some things are more clearer than others. So for example, especially, again, I'll give lighting because it's just so appropriate in especially for WA context. If you have some lights so far away and you have to drive to fix it, right? Or you have to drive to go monitor, because that's what's happening now. For example, Western Power, as they just put a few guys in a truck and they go around because they don't have that information. Now, when you start thinking about how often that light was broken in the past, that's when it makes it interesting, because that labor cost now is going to be offset. So yes, definitely in some of the use cases, it will be a lot easier to look into the predictive analytics than others.
Yeah, makes sense. We've got a couple of I love how people ask questions at 10:58. That's okay. Yeah. So James, do you have to go? Yeah, I'm just conscious of time. So we might.
Liz.
Yeah, no, that's absolutely fine. Jump off.
Thanks,
a couple
everyone.
of these questions are security ones. So Simon, if you're happy to stick around and answer these ones, then that would be great.
Yeah, more than happy to.
So quick one. So how can we potentially leverage AI, ML models, pattern recognition, etc., to identify any real-time malware injection? So how is, and I'm interested in this answer too, how is AI, ML being used around attacks?
Yeah, so you'll find that really good current intrusion detection systems already do have pattern recognition in that they can detect where traffic is coming from and patterns of traffic to, I guess, thwart DDoS attacks. But yeah, I believe there's another project, it's escaped me, Deep Impact, I think it's called, Deep something anyway, that they're actually utilizing AI and trying to get it to the point where it can detect real-time injections and indeed DDoS attacks at a very 98.8% accuracy, I believe. I'll have to find what the name of that is, so I'll get back to you with that in a moment. But yeah, I believe that they're already starting to utilize AI for that and for many other areas of cybersecurity as well, including even the human element of cybersecurity, which is your social engineering, your phishing attacks, your business email compromise, things like that as well. So it's not just on a level of take botnets and injecting malware, but it's also on the very probably more prevalent social engineering aspect of cyber, which is about 80% of attacks.
Yeah, and then I think that also goes to probably the next question around the automation of the connection of the IoT and security. So I think you've touched on that. I'll just one very final question, if you guys are okay to stick around for this one, and then we'll wrap it up. What would you suggest might be some of the best centralized IoT data platforms to enable a host of smart outcomes? So, i.e., in order to evaluate industry capability and minimize the number of tools needed. Do you know, Zreka, do you know what IoT data platforms are out there?
Yes, Cisco.
Yep.
Kinetic for cities. There's a lot, to be honest, out there. I think the challenge is really looking at how automated that process is, and obviously secure. I didn't talk about security because we have a distinguished speaker here, but yes, where it's hosted, how. So I think, well, we do have something, obviously. It's called Kinetic for Cities. We do see, a lot of, I think even Schneider has something. So yeah, it's difficult to comment, but there's quite a lot in the market at the moment. Yeah. However, proven in scale, not many.
All right, I think we will wrap it up there. So thank you both for your time. I found that extremely informative, and yeah, I think there's a huge potential in connected devices, and in particular around the smart city. So I'm excited to see where it goes in the future, and bearing in mind security. So thank you for joining us, everyone, on the webinar today, and please keep a lookout for future webinars from WODSI. And thank you again. Enjoy your day.
Thank you.
Thank you. Bye.
Have a good day.